Hi, my name's Andrew McLaren, and I want to help you with empirical formula problems that have a bit more steps to them. Oftentimes, when you're doing empirical formula problems, you just get things reduced down to the ratio where the smallest number is 1. But as you can see in this context here, the 1.5, you can't really round that. So if this had come out as like 0.99 or 0.105 or something like that, then you just do a little bit of rounding. But when you get things that are zero point 0.3, 0.5, 0.6, or something around that, oftentimes you need to multiply back up. So I've got a number of examples of chemicals where that would be the case. Off to the side here, you can see we've got aluminum 2O3. The problem here is that the smallest number in the empirical formula is not 1. So oftentimes when you get these numbers reduced down by looking at the moles as a ratio and dividing by the smallest number, you're going to get something that is not working. So if you had, for example, C₃H₈ as the compound, it would have a ratio of like 8/3. That's like 2.66. So that is going to mean that you can't round that to 3. Like this isn't C₁H₃. You need to multiply it back up. Same sort of deal as if you had that C₂H₅. If you were to try and go through these steps, you would get something like a 2.5. Same sort of deal here. This would be like a 1.5 or 1.5 for the hydrogen and the oxygen if you had this as like that first one to that second one. And all of these are going to be things where instead of rounding, you need to multiply back up to get whole numbers. It's much, much easier when you look at compounds like what we have right here for glucose, and the compounds are just like 1 in the empirical formula. So we usually don't write in 1, so I've just kind of written this out in a bit of an improper way of doing the notation, but just to highlight there's 1 carbon and 1 oxygen in this empirical formula. That is going to give you a whole number. So if you had like 2 divided by 1, that works out. So like this is going to be like a 1 to 2 to 1. So that when you do those steps going from a percentage, you would get either things like 1.02 or 2.03 or something like that, where like they're very close to the whole number, so you can just round it a little bit. So just beware of things that are like indicating like a third, a half, or 2/3 in the decimal places of these numbers. As you can see, there was like this, it's not actually 0.67, it's 2.67. Or if you had 1.67, like those types of numbers, you're probably going to have to multiply back up. Now you might see this with like 0.25 or 0.75, but those are much less often. Because like think about that. That's like saying you've got a ratio of like 5 to 4, or maybe like what would that be? Like if you had 1.75, that would be like 7 to 4. These types of ratios are much less likely to be seen in chemicals because most things are going to be not having the smallest coefficient, like of 4 or something like that. It's more likely to be like 2 or 3. So you're much more likely to see these as your ratios when you do these steps. Same sort of deal here for the CO2. That's a ratio of 1 to 2, so that would be mathing out pretty easy. Here for this compound, you're getting a ratio of 4 to 10 to 1. And so the smallest number is actually working out to being 1, and these other things would be multiples of that 1. So that is possible. So just because you've got large numbers on the other ones doesn't mean that you're disqualified. It's more about, are you getting something where you need to multiply both the 1 and the 1.5 up by some factor to get the empirical formula. Like in the context of the 1 and the 2.5, we had to multiply both of those by 2 to get a ratio of 2 to 5. Or like in the case of the 1 and the 2.33, if we multiply both of those by 3, then we've got a ratio of 3 to 8. So it's just like, what do I need to multiply up to get a whole number? So if you take that 2.66, you might be like, oh, this is like a 2/3. Maybe I can multiply it by 3. And that gets you pretty dang close to 8. So a ratio of 3 to 8 seems pretty reasonable for that. And that's where we're getting that, as well as our 2 to 5 kind of coming from multiplying up.